Hi everyone, welcome to another Steminism video. Today we're going to make a rainbow on a plate just using candy and water. This demonstration will explain a really interesting scientific process called diffusion. So just a little bit about diffusion. Diffusion is a process where particles move from an area that has a high concentration to one that has a low concentration, as you can see in the little diagram here. What this means is that they move away from really crowded spaces to spaces that are more empty for them. This lets them balance out evenly throughout any substance that they're in. Okay, here's an easier way to think about it. Let's say that there were two rooms connected by a hallway, kind of like what's shown in this picture right here. They're the exact same size, but one room has 200 people and the other has 20. Now, let's say you are just a person stuck in the room that has 200 people. So, for example, in the photo, you would be the person in the room on the left. So, it would be pretty uncomfortable, wouldn't it? Wouldn't you want like a little bit more space to be comfortable? And so to do that, you would move over to the other room. So you'd have to push your way through all of the other people, walk through the hallway and into the other room. Particles are exactly the same. They want their space to be comfortable just like you would, so they move from very tightly packed spaces to places where there aren't as many particles like them. Thanks to this, there's so many amazing things that happen in the world. Diffusion is the reason that you can smell good food or really nice perfume from far away, and today we're going to look at a really fun example of it. Okay, so the first experiment we're going to be doing is the Skittles Rainbow. To do this, you're only going to need three things: a plate, a pack of Skittles as shown, and a cup of water. The first thing you're going to do is place your plate down, open your pack of Skittles, and take them out one by one and place them in the circle with colors in any pattern that you would like. After you're done making your circle, take a cup of water and pour it into the middle of the circle. Make sure that you pour the water until it touches all of the Skittles in the outside circle. Alright, now we can just sit back and watch the magic happen. You're going to see diffusion in action. So the final picture will kind of look like this. What you'll see is that the color particles from the Skittles began moving into the water. Inside the water, there isn't any of these particles, so they start moving from the more concentrated area, which is where there are a lot of color particles on the Skittle, to an area that's pretty empty. The water does not have that many color particles in it. As it does this, it creates a really beautiful pattern. You can do this with any colors, shapes, or arrangements that you want. It makes gorgeous rainbows every time, and you can see diffusion in action. Another really interesting thing about diffusion is that temperature affects how fast it occurs. So let's go back to the example of the two super crowded rooms that we looked before. Someone who is tired or has lower energy will have a harder time moving through the 200 people to get into the room with 10 people, wouldn't they? And if you had more energy, you'd beat them to it and make it to the other room faster. Particles work the exact same way. The temperature of the particles is a sign of how much energy they have. The hotter they are, the more energy they'll have. If they're colder, they have less energy. Now, by doing a fun demo, we're going to race a system of hot water versus cold water to see which one has diffusion that happens faster. For this experiment, you're going to need a glass, which you will be filling with hot water and cold water. For the hot water, I just heated my water in a glass for 2 minutes. For cold water, I placed the glass in the fridge for 5 minutes. I also used two different colors of food coloring. I chose blue for the cold water and red for the hot water, but you can choose whichever colors you'd like. So first I took one of the glasses and I put 2 drops of food coloring into the glass with the cold water. And then I made sure to take 1 minute of time and I just watched how the blue changed. I repeated this with red food coloring in the hot water the same amount of time. And if you watch very carefully and compare them to each other, you'll see that it takes much more time for the blue color to spread throughout the water than it does for the red. This is because of the temperature difference. The higher temperature causes diffusion to happen faster, as we talked about before. So if you watched it for long enough, as shown in this video, you'll notice that eventually the water all becomes the same color. This is called equilibrium, when the color particles have become evenly distributed throughout the water. Again, let's go back to our two-room example. The most comfortable situation for everyone in these rooms is for half the people to be in one room and the other half to be in the other, isn't it? Well, this is exactly what equilibrium is. From the super crowded room of 200 people, if 90 people leave to the room with 10 people, there's going to be 100 people in each room. This will make absolutely everybody comfortable, and people will not move between the two rooms anymore. They will be evenly distributed. This is the exact same thing that happens to the water and color particles. The super packed together, concentrated color particles move across into the water and mix evenly. To summarize, in this video we explored the basics of diffusion using some really cool demonstrations that use colors to show the process. I hope you've enjoyed these experiments and you've learned a little bit about a new topic in science that's really important for a lot of things to work as they do in the world that we know today. I hope you have fun making really pretty, colorful rainbow Skittle patterns. The room for creativity is endless. Thank you!